In this video, we're going to learn about hydraulic system, and they are actually all around us. For example, a car jack where you can jack up the car to change your tire, just doing it manually, or a forklift. In this case, it's a manual forklift. You apply a small force and then you can lift up a heavy load. Or they are commonly found in excavator, where you can see this kind of piston. These are actually hydraulic system, and it's very commonly found in amusement park also, where they lift the carriage up or down. Another very common thing is the braking system in the car, where you exert a small force using your foot on the pedal, and because of this hydraulic system, the output force is actually very large. That's why the force of the braking pad is higher, and then you can stop a car. At the bottom here, you can see a typical hydraulic diagram where you have two pistons. On the left hand side, the piston has smaller cross-sectional area, as you can see at X here, and the other end, piston Y, it has a larger cross-sectional area. So in general, a hydraulic system allows you to exert a small force Fx here at piston X with a small cross-sectional area, and the piston which has a higher cross-sectional area will achieve a much bigger force. Depends on the ratio of the cross-sectional area. So for a hydraulic system to work well, besides the fact that the cross-sectional area of the two pistons must be different, another thing is, in a hydraulic system, you have to use hydraulic oil, or in general, you must use a liquid, not a gas. Because in the liquid, using the Pascal principle, when a pressure is applied to an enclosed liquid here, the pressure is transmitted uniformly or constantly throughout all parts of the liquid. So when you exert a force at piston X, this pressure, because it's liquid here, the pressure at any 2 points inside the liquid will be the same, and that's the key concept. And then you can find the output force Fy over here using this concept. So if you use air, because as you know, you have learned, air molecules, they are far apart, a lot of empty spaces between them, so the air will be compressed. So whatever work done using conservation of energy, most of the energy at piston X will be converted to work done in compressing the air. So a very little will go to pushing up the piston Y to lift the load. So for hydraulic system to be efficient, you have to use liquid, or in general hydraulic oil, because the liquid molecules are closely packed with little empty spaces between them, and they are able to slide around one another. So that means to say, all the work done that's exerted by Fx, most of it in the ideal situation, all will be converted to work done in lifting up the piston Y to lift up the load, and the pressure is transmitted uniformly throughout the whole liquid, and the pressure will be very high. Next, let's use the concepts that we have learned to solve for the unknown Fy, the output force. So firstly, because the pressure is transmitted uniformly, so pressure at any 2 points inside the liquid will be the same. So in other words, pressure at point X is equals to pressure at point Y. And we have learned previously that pressure is force over area. So under pressure at X, it will be force X by the input force over the cross-sectional area of the piston X. And for pressure at Y is due to the force at Y, which is the unknown, over the cross-sectional area of piston Y. So it's AY. Next, let's sub in the value. So the input force Fx is given 50 Newton, and the cross-sectional area is 2 meters square, and Fy is the unknown, the output force that we want to find, and the cross-sectional area is 5 times bigger, is 10, and if you solve it, your Fy will be 250 Newton. So as you can see, because the area of the piston Y is 5 times larger than piston X, therefore the output force will be 5 times higher than the original 50 Newton, so it will be 250 Newton. What if they were to ask you to explain why is it that Fy is greater than Fx, the input force? So you will still be using the same concept because pressure is transmitted uniformly throughout the whole liquid. Therefore, pressure at X equals to pressure at Y. And using pressure equals to force over area. So since the area of Y is much greater than area of X, okay, so therefore since the ratio is the same, the pressure is the same, therefore your Fy will be much greater than Fx. So you'll be using this same concept to explain. Now if you come and think of it, isn't it a wonderful system because you only apply a small 50 Newton force at piston X and yet you achieve a 5 times more force at the other piston Y? Isn't that great? But the thing is, there must be a compromise because conservation of energy will definitely apply. And what's the compromise here? And I think you should have known, just like those hydraulic jack, you have to jack so many times in order to move the load up a little bit. Just like this, the distance moved by piston X is 20 cm. And how do you find the distance moved by the Y? It will be very much lesser compared to distance X. And let's find the value. To solve this, we'll be using conservation of energy that you have learned. So basically the work done on piston X is equals to the work done in piston Y. And of course, we are going to assume a very ideal situation where no energy is wasted in the form of heat or sound or whatever. So, and how do you find work done? If you can recall, force times distance. So in this case, it's your force X times your distance X, and that will be equals to the force Y times your distance Y. And let's submit the value. The force X is 50 and the distance moved is 20 cm. And the force Y, we already found that it's actually much bigger, 250 newtons. And let's solve for distance Y. And if you solve it, the distance moved is only 4 cm. So you can see that there's a compromise. Even though you end up with a big force at the other piston, but the distance moved is actually very small because conservation of energy will still apply. But this system is still good because with in general, a human force, okay, it's actually very small, but yet through this system, you can actually achieve a much higher force, even though the distance moved is actually very short. So likewise, if it is an explanation question where they ask you why is it that the distance Y move is actually much smaller than the distance X, so you'll be using the same concept, conservation of energy, and the work done in piston X is equals to work done in piston Y, and since work done is force times distance, so you continue to explain since the force Y that you achieve is much greater than the force X, therefore using conservation of energy, the distance moved by Y will have to be much smaller than the distance X because both sides must be equal. So that's how you explain this.